Thank you all for coming around to this session. Me and Samuel were actually here last year at Future Frontend. Both of our first times in Finland, I'd say. I think so, yes. Yeah. It's a lovely time, honestly, and such a great first year and great to be back here. So last year we did separate sessions. I did a talk about design systems. Samuel did a talk about authentication and authorization on the edge, and we thought, you know, why not just see if we can do something together and merge some of our different things that we do in our day jobs and see if we can get something cool out of it. So this session is called From Static to Dynamic, and we're going to talk about a bunch of different concepts and see if we can tie them all in together and do something interesting and hopefully leave you all with a little bit of inspiration to go and create something a little bit crazy in your spare time. So, as Yanni mentioned, my name is Mo. I head the mobile team at Theodo. So Theodo is a group of about 700 digital experts across France, UK, the US, and Casablanca. And I specifically work with a sub-company within Theodo called BAM, which does mobile development stuff and has been doing React Native since 2016. So I'm very involved in the React Native community and try to see if we can find good ways to take React Native to the web, which I've been talking to Yoav about extensively, and he tells me that the answer is PWAs. So I may be reinventing the wheel a little bit.
My name's Samuel. I do nothing so fancy. I'm a plain old systems engineer at Cloudflare. I work on developer productivity and developer experience on the Cloudflare Workers platform.
And as you can see, his humility is far better than I am. Cool.
So we've come here under false pretenses somewhat. We'd like you to go to this website and buy some clothes. Or at least that is what we'd say if we'd actually built it. So this is a kind of fairly bog standard e-commerce site. It's got, you know, recommended products. Wait, no, I have a clicker, don't I?
Yeah, you do.
Okay, excellent. Featured categories, testimonials, and a footer. It's fairly standard. There's nothing complex here. You've probably all written sites like this or seen sites like this. And if you're thinking about implementing it in something kind of JSX inspired, so React, Solid, something like that, you might have a home page and then components for each section of the page. This is fairly bog standard code, nothing interesting. You'd write this, you'd ship it to production, everything would be fine. However, at some point, the PM, your clients, stakeholders would come along and say, actually, I want these sections rearranged. You'd grumble a bit, you'd rearrange the sections, and it'd all be fine. Wouldn't actually take that much work. And a couple days later, they might want to rearrange some more sections. You can maybe start to see where this is going. You start to get bogged down in a lot of kind of rearranging of UI work you don't really want to be doing. You want to be building complex dynamic interfaces. Instead, you're rearranging UI. And eventually, it starts to get even more complex. They might want to have specific state depending on whether the user is logged in. And you know, you can do that, but it starts to get a bit more complicated. And then eventually, these animations are very slow. Eventually, they're going to want kind of very, very highly dynamic state based entirely on the user. So completely complex, completely custom layouts per user. And your house of cards falls down. This is not the type of stuff you want to be doing. You want to be building complex, interesting interactions. Instead, you're just rearranging the proverbial deck chairs on the Titanic.
And, you know, for some developers, it may just be mildly frustrating. For other ones of us, it might elicit slightly more aggressive reactions. And none of us like to do this in the workspace. So we're going to look at ways where you can prevent yourself from smashing your laptop, your Mac, whatever you have as your daily driver. And one potential solution to this is a paradigm that's been around in front-end development for quite a few years now. It's nothing new, server-driven UI. So the whole concept with server-driven UI is that you allow the server to define the layout of the page via some form of serializable data, so in this case JSON, and then you create a dynamic layout component on your client side that receives that JSON and can render the page dynamically and in any order that you want. So there's no more hard coding left here. And on the right-hand side, you can see an example of what that JSON payload might look like. It's got an array that's got a set of components. So in this case, let's go back to the e-commerce example. You've got a banner, you've got offers, and within each of those objects, it also defines the props, what you need to pass through to those components to render them accordingly. So, you know, the banner might take props for some contact information. The offers might have an array of the different items that are currently having a price reduction, and so on and so forth. And this comes in various different shapes and sizes. You can use server-driven UI for your entire page in your application. You can use it for sections of your application. Or you can even use it for certain components. So as an example, Lyft has used server-driven UI for just a single sheet within their mobile applications. It's a single component, and that's because there is a lot of different slight variations, and they wanted to be able to configure just that from the server as their business started to evolve and have different requirements. And so if we look at a very basic example of how this would look like in your code base, first thing that we need to do is we need to create a map between what the server is returning in strings within the JSON objects and what components they map to within the code base. So we'd import the components. This is not a production-ready code, so don't use this because it'll break all of your tree shaking. But you can use this with dynamic imports and it'll work as expected. You would define a components map and say, when I get the string banner from my CMS or endpoint that's on the back end with the layout, I want it to map to this specific banner component in my code base, and the same for offers. And then we'd have a render component function. So this render component function takes in a config in the shape that we're expecting the server to return to us. It then looks at that config and says, what is the component you're asking me to render? In this case, it might be the banner or the offer, and then it basically returns that. Very simple, passes everything in through props to the already existing component. And so our homepage is a lot more dynamic suddenly. So if we look at the new implementation for our homepage, we have a loader to get the JSON data from our endpoint or our CMS, and then we basically just loop through the JSON data and pass it into that render component function. It can obviously be a bit more complicated, but in the example where we had just a one-dimensional scrolling sort of set of components, this is pretty much it, and you can get it to work. And so combine the JSON from the API and the CMS and the home page, and you have a fully layouted page that's customizable and dynamic and can have a lot of different benefits like personalization. And so it takes us to common reasons why people do server-driven UI. We've seen complex layouts and variations that'll change all the time. People oftentimes want to increase dev velocity because what you're doing is you're taking away a lot of that manual, small, tedious work that your front-end teams are doing and just moving that to another part of your stack. User personalization is a big one. Oftentimes, people start to reach out for server-driven UI when you have user personalization needs. And in that same vein, you've oftentimes got A/B testing requirements, and doing server-driven UI makes it incredibly easy to do A/B testing, not only on the web, but also on mobile, where you have native components, and actually shipping updates might be quite difficult. And lastly, we've seen if you've got those complex and fast-changing requirements, it's a good place to consider server-driven UI. But the one that I think is very interesting is around user personalization. And this is very much what modern front-end applications are expected to have. Every single app that you interact with has some level of personalization for you, whether that's going to an e-commerce site and it shows you the products that are most relevant to you, or it's even a single-page app that has some level of personalization and keeping a state of what you've done to try to make your experiences more streamlined and more smooth. So users really do want seamless handoff of state between sessions and devices, and sometimes this is actually quite minute, and they're very tiny micro-interactions, and we'll look at a few examples. And when we talk about state, that oftentimes includes ephemeral state, things like your search history, things like theming that you've set up in your application. You don't want to be setting these up every so often because it's not being persisted correctly and across different devices. So let's go through an example, and I think that'll make it land a little bit better. When I wake up in the morning every day, I usually start going through my mails on my phone. I'm walking around the house, getting coffee ready, sometimes lying in bed because I'm lazy, up till 9:30 when my work starts, and I jump into the first meeting. Not a good idea. And sometimes, I'll have an email that requires a little bit more attention and needs a little bit more screen real estate. So this was an email from a conference organizer. They needed some details from me. And on an OS level, we actually see this seamless handoff of state quite commonly. So anyone who's in the walled garden of Apple these days, they'll have the handoff feature. That means that your interactions will kind of be synced across different parts of the OSs. So you're viewing a mail on your iPhone, you open up your Mac, and there's automatically a dock icon at the bottom of your screen, and it says you can open up the mail from your iPhone. And when you do that, it's in the exact same state as you were on your iPhone. So there's a seamless handoff across devices in a single session. And then you can kind of continue through the flow as you wish. But this isn't only on an OS level. This happens on an application level, right? So in the case of, let's say, Google Maps, a common app that we all use, that state is consistently synced, and it's the same with most of Google's applications across different devices and across sessions. So this morning, we were looking for directions to the Oodi. Anyone who's not from Helsinki here, who hasn't been to the Oodi yet? Raise of hands. Absolutely should go. Do not miss this opportunity. Best public library ever, hands down. So we were looking for directions. I get distracted very easily. I'm sorry. And when we looked up for the directions on the phone, when I opened up my phone, it was already there. I didn't have to search for it anymore. It was automatically synced without me even having to think about it. So I could just click on that button, and it was done, dealt with, easy.
But your backend teams are busy, and they don't want to think about this kind of syncing of ephemeral state. They want to focus on building new routing algorithms or building mail architectures. They don't want to focus on building syncing logic for which email is open in your client. And what if front-end devs didn't need their back-end teams to do this stuff? What if they could build the syncing architecture themselves?
And that's where the demo comes into place, right? So let's go through an example. We've started with maps. Let's just keep going with the maps example. So we've built a very basic maps example in React Native. The same would be applicable with a React app, so you might have different applications. And currently, the state is separate. So let's imagine I've got an iPad here, and I've got an iPhone, and I want to actually sync the state between these. Well, currently, that's not the case. So I can search for a location. In this case, maybe I want to search for Helsinki, and then do a search. Right now, it's not synced, right? So if I go into my search history here on my phone, there's nothing in my previous searches. I can search for London, and I can go to London here, but it's not going to show up on my iPad. So these are two very separate experiences. They're not synced in any way possible. Other things like theming. Right now, I'm viewing it in standard mode, but maybe I just want to view everything in satellite mode. But that's not going to be synced across the board. And so me and Samuel were thinking about, what is, as a front-end developer who doesn't do a lot of back-end, what would we want to make it easier, or as easy as possible, to simply take us from the front-end world and allow us to write back-end code, right? We don't want to be dealing with a lot of complexities that come with back-end development, but we want to find a seamless way that we can move some of the state over to a server somehow. And so we got thinking, and I'm going to open up some code here. Let's make sure my connection's still working. Good. Cool. So we got thinking, and we said, well, yes, that's a good shot. Yes. Back of the screen, back of the room, can you all see this code? Sorry? OK, well, let's see if we can make it light mode. Theme. Does everyone like solarized light these days? OK, cool. All right. Nice. So obviously, at the very top, we've got a bunch of use states, right? This is the way that we're used to. We have these hooks in React, and every other framework has their own set of primitives, right? That you can keep store and keep state within the client side. And so we're used to this use state API nowadays in the React world, where you simply create some state and keep that on the client side. But what if we could just, change use state to another hook and just call it, I don't know, use server state? And that could just automatically push that data over to some server that lives somewhere. Now, obviously, it's a little bit more complicated when you're pushing things to a server. Let's just give it an ID and say, this is my maps demo ID future frontend. And if I save that, and I reload my application, because it's what if I just searched here for London, let's say, as a location? And then on this side, I wanted to open it up, and it automatically had London synced somewhere on a server without me needing to add any extra code. So 2 words added, and it can suddenly sync, right? So that, to me, as a front-end developer, is incredibly easy to get my head around, because I simply need to add an ID to my use state so that it's globally identifiable, and then I just change the name of the hook, and it just kind of works. It feels very intuitive. It makes me want to just move as much as I can to a server, and it doesn't make me fearful of all of the changes there. So let's just go and add a bunch of more use states or use server states to this. One thing that we saw was the theming here. The theming is not synced across the board, so if I change this, it won't sync across the other one. So what if I just change this one to a use server state, and I just called this one map mode future frontend. Save that. Great. It's all synced with one simple change. Let's go through the process and just change more and more. It's really quite simple here. So let's just say I want to change the region that's currently selected. So region, future frontend, let's save that. And now this one starts to get fun, because I can search for Helsinki, And not only will it navigate on my iPad, but it'll automatically point that towards the one on my iPhone. You can start to really break down what good UX is and really ruin the user experience with too much syncing. But we'll do it for a bit of fun. So that's synced. OK, cool. Let's change this back. And then just to make matters worse and even more confusing, let's just sync the query. And we'll call this use server state. And maybe we'll give it an ID of keylogger, because this is definitely an awful idea. And then whatever I type here is synced across the state. So I can kind of remove things, and it will be synced across the state there. So that's just a little glimpse into what we think syncing state should look like when you are a front-end developer and don't want to write back-end code. Now, how does this actually work, right? We've kind of shown you just a little bit of magic. We're obviously using a third-party library here that we've built and just said, look, it works. And that's what Samuel's going to take us through, is how this actually works under the hood. And you'll realize it's actually not as daunting as it might seem.
This is a first-party library. So quick aside, I'm going to go through a couple slides from my talk last year at Future Frontend. If you've seen these before, avert your eyes. If you haven't, then pay close attention. Just to kind of set some groundwork. So the speed of light is slow and your users are global. I like this catchphrase because it's a good catchphrase and it's also quite true. If you're in Helsinki, or your servers are in Helsinki, and your users are in London, you're looking at about a 30 millisecond kind of connection ping latency delay. So that's the speed of light. It's the network latency along the cables, undersea between Helsinki and London. And that is time that's completely wasted before you even get to your application. So if your application is doing any rendering, it's doing any loading client side, is there any image, waterfall loading, you've already lost 30 milliseconds. And Helsinki and London are quite close. If you look at Los Angeles, it's 180. Tokyo, it's about 230. And then by the time you get to Australia, you're looking at about half a second before you can get anything to users, not accounting for anything that your application wants to do. So a different model of doing this is to run your servers on the edge, or to run your code on the edge, and just bring compute much closer to users. This is a map of Cloudflare's network locations, but every CDN provider has computers around the world. Fastly, Akamai, CloudFront all have things that kind of map roughly similarly to this. And the idea really is to just run compute as close to your users as possible. So you don't have any kind of network connection latency. All of the delay is stuff that your application is actually doing, useful stuff that your users want. So I'm going to quickly talk about durable objects. And durable objects are basically a way to have stateful serverless. And what do I mean by that? Traditionally, serverless, as you usually think of it, is effectively stateless. If you think about lambdas, it's a request comes in, you do some data mangling, you might go to a third-party API, and then you return a response to users. But at that point, it stops. If you need to think about storing state, if you need to think about user application data, you need to reach for a third-party service. You need to reach for DynamoDB. You need to reach for RDS. You need to think about regions. You need to figure out if you're accessing the right region, if you have the lambdas in all the regions you need. It starts to get really complicated. You hear lots of buzzwords. You hear lots of words. And if you're anything like me, you kind of start to get a bit terrified, because I don't understand how any of that works. And there's too many concepts. And durable objects are kind of a simpler way of thinking about that. It's basically an instance of a JavaScript class with some storage. And that's all it is. And that's all you need to understand. Most of you will know how to write a JavaScript class. If you know how to write a JavaScript class, you can write a durable object. So this is a really simple durable object. You can see all it is a class definition and a function that stores some data. That's it. And you can write this, and then you can deploy it, and it will be close to your users, wherever it needs to be instantiated, and the data will be persisted and stored. This is obviously a fairly simple one. And then this is how we connect to it. But the actual durable object to support the use server state hook is really not that much more code. Because the really cool thing about durable objects is because you have this stateful serverless primitive, you have this long-lived process which can have connections, you can think about WebSockets. You can think about things that don't traditionally fit into the request-response model. Because for lambdas and for most serverless primitives, you get a request, you do some stuff, and you return a response, and it ends. And that makes it really, really difficult to support things like WebSockets, which require a long-lived connection and which require much more time. But here, all we're doing is saying when a WebSocket message comes in, we store some data, and then we broadcast it out to every other connected client. And that's all use server state is. It just takes in updates and broadcasts them out to everyone else that's connected. And then the client side of this is really not that much more complicated. Your React code, the components, will send in updates to the use server state hook, which is client-side code. That use server state hook will say to the server, hey, I've got a new update, do something with it. The server will then broadcast that to every single device that's connected, and they will then go and update their own things. But those other devices can also broadcast, and then that will come back from the durable object, back to use server state, and back to your component code, and trigger re-render. And then going through the actual React code of this, we've got some boilerplate here for setting up a WebSocket connection. And then we have a local use state cache just for optimistic updates. The concurrency model here and the consistency model here is pretty naive. It's basically last write wins. You might want something more complex in a real application. And then we have a couple lines of code to take updates from the server, and then a couple lines of code to send updates to the server. But that's pretty much all it is. Any update that comes in from the server, we write to the local use state, and any set state that we get, we just write back to the server.
And this is effectively less than 100 lines of code. And that's 100 lines of code on both the client side and the server side combined together.
And half of those are braces and types.
So you can really get this to very minimal code that's running on the edge and a very slight abstraction that will allow you to sync state like this pretty seamlessly, I'd say. And the thing that's important maybe to just take a step back here is this is not something that we would be looking to open source because it doesn't make sense to open source it. It's a very light abstraction. But the kind of fundamental concept that we want to get across here is you can write your own use server state hook and very easily create the right abstraction for the entire front-end team that you have with your authorization and authentication set into place and with whatever sort of conflict resolution algorithm you want already in place, and then you can make it a really nice experience to move state from local to somewhere that's shared on the edge. And we think it's a really cool abstraction that more and more people should adopt. And so we've talked about ephemeral state that's represented as JSON. So this was things like our search history being stored in a JSON object. And they are then hosted on the edge within a durable object. But earlier in this talk, we talked about server-driven UI JSON. We said you can represent your entire layout and your entire application's state and how things are being rendered in some sort of JSON that lives on a server. What if we just put that server-driven UI JSON inside of a durable object? And so it turns out when you take server-driven UI layouts and you add some ephemeral state into them as well, then you can create some really cool real-time collaborative applications. And there's no better way to do it than a demo. So I've asked some very lovely people from both the speakers and one of the great people from the audience who I've known for a little while to come along and participate in this interactive demo. So please welcome everyone with a warm round of applause onto the stage. Nope. Fuck. That would have been disastrous. Cool. Come up. Awesome. So I'll let you go through and talk us through, Samuel.
Okay, so this is a video calling application that is potentially going to break disastrously, so be prepared for that. So has everyone joined? Excellent. Okay, so we can see there are 5 users in the room. I'm going to join from this computer. And we can now see, excellent, lots of video streams. Now, there's a couple key things here. One is that this is themable, and that theme is synced across all devices. So these kind of confusing buttons here, you can change all the video to grayscale, and that will now be grayscale on everyone else's device as well. So if one of you could turn your phones around and show that. Now, what I was about to get to is that they can also control the theme, so clearly some people are exploring with the buttons. And this gets quite fun, because the theme is being controlled by effectively everyone.
This is Shrek mode here.
This is Shrek mode, yes. And this is Ghost mode. So that's one thing. The other thing, and this is straight out of a Black Mirror episode, is that you can vote your video participants. And the layout on the screen of the order of the icons is based on their score. So if I vote people down, they'll go down in the rankings. If I vote people up, they'll go up in the rankings. And the cool thing here is that this is live, synced across everyone. So this is layout driven from the server, but synced across all devices, and being able to be driven by all devices. Now, the next part of this demo is that we're going to try and let all of you join.
This is going to go poorly.
We're going to see what happens.
Yeah.
I've got a QR code. So if you would like to scan that, if you're using an iPhone, please turn off private relay. It somehow messes with WebRTC. But if you'd like to scan that and join the video call, and let's see what happens.
This will definitely break.
We have at most tested this with 5 people, so goodness knows what's going to happen when more than that join.
Oh, we've got audience attendees jumping in. Cool.
Cool. So I'm going to go back to, oh my goodness, that's a lot of people.
Andreas, I see you. I see you there.
So everyone on the call should be able to control the theme, and that should sync across every single device.
Oh, now we don't have any space. We didn't test it with this many people.
Oh, has it run out of space?
No, there's only a downvote button now, and no more buttons. So.
Okay, it may not be the most optimal mobile
So
UI.
we can start voting for people on the. Oh, and that's giving too many people too much control. Okay.
Yeah. Okay, so this has definitely started to break down.
Cool, but you get the idea, right? You can all just jump on a call, control the layout together. Obviously, probably not with however many people are in this room, but we've got a pretty cool state, and everyone's downvoting each other, which is great. So the social experiment has proven that it would be not very good, so we can go back. Thank you all for joining this. Thank you all for coming on stage. Round of applause. Cool. So we've taken up a lot of your time. Let's quickly recap everything that we've gone through today. Firstly, we talked about server-driven UI. We know that it's a way that you can handle complex layouts that need to be dynamic and personalized. These are layouts that are changing quite rapidly and need to be personalized potentially per user and really tailored. We know that users expect modern and future front-end applications to have seamless handoff and sync state between devices and sessions. And we found a good way to store ephemeral state on the edge, and it could be a good option because it's incredibly simple for front-end devs to adopt, and there's very low latency. We've obviously used DurableObjects, but you can find other solutions that are simple to deal with yourself. And then when you take the server-driven UI aspect, you take the state that lives on the edge, and you kind of put them all together, we can create real-time collaborative applications without needing any complex backends. The call demo that you saw was basically WebRTC on one side and effectively the same use server state that we initially demoed, handling the layout and doing all of the customization. So all of these things put together, we think, opens up the door to create something really cool, and you can hack around with a bunch of your friends and see what you can build, and hopefully you don't build something as dystopian as we did. Thank you all very much for listening in. That is our socials if you want to stay connected or shoot us a message. And hopefully we'll chat with you all a little bit more in the Q&A. Thank you. Right.